Hello everybody. In this video I wanted to talk a little bit about the issue of refresh rates of rendering versus update, which is moving stuff in the scene. So say we have this timeline and have 2 seconds and we're rendering, and the renders just take some random amount of time for each frame. Obviously in this illustration it's going to be a very low frame rate, but it's just for the purpose of illustration. And also we have to update the scene just before rendering each frame, so we have some animation and stuff, and then we just do the update just before the start of the rendering of the next frame. The problem with this is that our updates are going to happen at some randomly distributed intervals that are not equally spaced, as you can see. And the issue with that is that we have the problem because we want to move things at some constant speed most of the time, and it's going to be challenging to do that. So what we do want is to move things at constant speed, but what we actually have is we render frames at some random speeds that are not consistent. So what should we do? So there's a couple of common approaches to that problem, so let's start covering it. The first thing is the first approach is the most common one. We just cap the frame rate to some constant interval value, so say 30 frames per second or 60 frames per second. And after each frame we basically wait until we reach the next interval that we're aiming for. So we basically just do nothing for a while. We call it cap and wait. So okay, so say we have this timeline again, and we're subdividing into some equally spaced intervals. We're still rendering things that could still take random durations for each frame, but we're guaranteeing that we only ever start rendering the next frame, every frame basically at a consistent interval. So when we do the update, if we're doing it just before rendering each frame, then the updates themselves end up happening at intervals that are equally spaced or constant. So it looks kind of like this. So we update, then we render, then we wait a bit, as you can see, before the next update. And then we update, and then we render, and then we wait a bit more in this case because the next frame took a bit less. And we update and we render, and this time it took longer, so the leftover time is less, etc. So it just goes like this. Let's see some pseudocode, see how it looks in code. So we have the equally spaced intervals here in white, and the updates on red, and render in blue, and the varying gaps there. So we want to update and render. What do? Just before the update and render, we take a time measurement, and also another one just after that, and we take the difference between them, which is the duration that it took to do the update and the render. And then we compute the gap that is left over, and from where we are currently up to the next time interval, by just taking the constant time interval and subtracting the duration that we took. And then we just wait. Wait that gap and just do nothing for a while, sleep or whatever. An alternative way to waiting is to just burn cycles, and maybe more expensive, but it could also be a bit more precise and accurate. So what we do is just run a while loop. As long as the duration is less than our constant interval, we just take a new duration, measuring the time again of the current time, subtracting the same before time, basically growing the duration bit by bit until it matches or passes the constant interval. Okay, so that was one approach to solve the problem. Another approach is that we simply say we can vary the speed at which we move things proportionally to the time it took to render the last frame, such that if we theoretically could modulate it proportionally to how much it takes to render the next frame, that will be the ideal case. because what ends up happening if we do that is that frames that take longer to render, we also move things faster, right? So between the frame that we see to the next frame, it takes longer, but also things move faster, so it ends up looking like the same speed, like constant speed. So let's see how it looks. So in this time, we don't subdivide the timeline to equally spaced intervals. We just render one frame after another, and we have our updates, and as you can see, our updates are not equally spaced and kind of randomly spaced. But we can counteract the updates by modulating the speed in the following way. So we take the measurement of time of the prior frame, and then for our updates, we move things proportionally to how long it took to render the prior frame. And say the next frame took a bit less, so then the next update is going to be moving things a bit slower. And then the next frame takes a bit longer, and then the next update we move things faster, etc. Now, as you can see, it's some offset to where we would have wanted to be, right? If we could have done it, if we could have predicted the future perfectly and know in advance how long the next frame is going to take, we could update things in perfect proportion to that. But we can't, so we do it in kind of an offset. So let's see how that looks in code. In practice, by the way, that bit of offset is generally not noticeable if you're running at a pretty high frame rate. Most people won't be able to tell that that's happening. They'll still feel perfectly constant speed and smooth. Okay, so we take in this case we subdivide we split the update and the render codes between each other. We don't do them at the same time or like right after each other. We take a time measurement between the update and the render, right? And that's going to be like the time measurement of the last frame that we did. So just after we update and just before we render, we take a measurement. Then we take another measurement that measures the time between that and just before the next update. So we kind of do the opposite of what we did before in terms of accumulating the time. And then we have, just before the update, we have the time since the last update finished, right? And then we modulate the speed at which we're moving things by that time duration. So that's how that looks. Another way of doing things is doing the same, but also we can decouple the rate in which we update and move things from the rate in which we are rendering. How does that look? So we do the same as before, but as you can see, the spacing of the update is wider than the spacing of the render. So how do we do that? So we basically end up accumulating time over potentially more than one frame, multiple frames, and then we try to target a specific update refresh rate. We won't hit it exactly, but we can aim at it. So that's how it looks in terms of time measurement. And let's see the code. So we have the same story as before. We take a timestamp at just after the update, just before the render. We take another one just before the update, but we don't use that measurement itself. We instead accumulate it to some value that gets accumulated of all the time. And then we measure that accumulated time against our update interval target. We probably won't ever hit it precisely, or it's unlikely. But just when we pass it, then we do the update and we modulate the speed not by the time since the last frame, but by that accumulated time. So we end up achieving the same goal of having things moving constant speed. That's it. If you've enjoyed the video, you can hit the like button. If you'd like to be notified for any further videos like that, we can subscribe to the channel. And that's it. Thank you. Bye.